Welcome to today's explainer. Every single second, the world around us is just buzzing with activity. But rather than chaotic randomness, all this movement actually follows a beautifully structured system. So today, we're diving into the mechanics of motion, a kinetic overview. Let's completely demystify the everyday physics of movement and uncover the hidden framework behind literally everything that moves.
So, let's kick things off with a pretty fundamental question. Why do cars move down the street? Why do birds fly through the air? Or, zooming way out, why do planets orbit the sun? It is super easy to just look at a bustling city street or the night sky and see random, disconnected activity. But the truth is, all of these phenomena fall under one unified scientific concept. They're all examples of motion. But to really grasp what's going on, we need to nail down exactly what that word means.
All right, Section 1. What is motion? Let's lay down the absolute foundation of movement.
The absolutely crucial point here is that motion is strictly defined as the change in position of an object over time relative to a reference point. It's not just that a car is rushing by. It's rushing by compared to a stationary stoplight on the corner. An airplane is traveling relative to the ground way down below. Without that reference point, the whole concept of motion kind of falls apart. That anchor is what makes the measurement possible in the first place.
Moving right along to Section 2, linear motion, or moving in a straight line.
So linear motion is exactly what it sounds like. We're talking about traveling from point A to point B without any curves whatsoever. We see this dictated by physical constraints all the time in the real world. Think of a train restricted to a straight railway track, or a person walking directly down a straight path. But keep in mind, linear motion isn't just horizontal. When gravity pulls a ball straight down toward the Earth, that free fall is traveling in a direct vertical linear path. Straight down is still straight.
Up next is Section 3, circular and rotational motion, the actual physics of going around.
Now, people mix these two concepts up all the time, but the distinction is actually fascinating. Circular motion happens around a fixed center in a circular path. Think of the Earth revolving around the sun or the hand sweeping across a clock. The center point is entirely outside the moving object. Rotational motion, on the other hand, happens when an object spins about its own internal axis, like a spinning top, a bicycle wheel, or the Earth rotating to give us day and night. It's a subtle tweak, but it's an absolute game changer for understanding how objects behave in space.
Section 4 brings us to oscillatory motion, that classic to and fro movement. So oscillatory motion is defined as the to and fro motion of an object around its mean position. Those two terms right there, to and fro and mean position, they are the absolute anchors of this whole phenomenon. Unlike linear motion, which just goes from A to B, or circular motion, which loops around, oscillatory motion is completely bound to a resting center point, and it's just constantly snapping back and forth through it.
To really see this to and fro mechanic in action, picture a classic pendulum in a physics lab. It swings out, pauses for just a fraction of a second, and rushes right back through the center. Now scale that exact same physics up to a kid playing on a playground swing. The underlying principle is 100% identical. You can even hear this type of motion. When you pluck a guitar string, it vibrates back and forth incredibly fast around its stationary resting point to blast out sound.
Finally, Section 5. Motion is everywhere. Let's bring this all together.
By taking a step back, we can now take all that chaotic, random movement of our daily lives and sort it neatly into 4 distinct buckets. It's like a giant puzzle falling into place. We have the straight, linear path of a falling ball. We've got the circular, fixed center loop of a ceiling fan. We have the internal, rotational spin of a toy top. And rounding it out, the oscillatory to and fro rhythm of a swinging pendulum.
We've built a pretty solid framework today, so I want to leave you with a final thought to chew on. Take a second and just look around you right now, wherever you happen to be. What types of motion are you experiencing at this exact moment? Is there a fan spinning above you? Are you traveling in a straight line on a train? By understanding these core kinetic categories, you literally have the tools to decode the constant energy of your own environment. Keep observing, keep categorizing, and as always, keep learning. Thanks so much for joining.